Hey everyone! Today we're going to be dividing rational expressions. So before we do, let's just recall how to divide rational numbers. So let's look at this first example. If I have 1/3 divided by 2/7, what we do is we actually multiply the first rational number by the reciprocal of the second number. So we flip this second fraction around and we end up with the product of 1/3 times 7/2. Now, just as we've already looked at before, when we multiply two rational numbers together, it's the same as multiplying the two numerators together and multiplying the two denominators together underneath the division bar. Now we simply multiply 1 to 7, which is 7, and 3 to 2, which is 6. And that's our final answer. Let's review the process for one more example. Example 2. I have the fraction 1/2 divided by 3/8. But again, as we just reviewed, multiplying by the reciprocal of the second fraction is our next step. Now, we multiply the two numerators together, 1 times 8, over 2 times 3. Before multiplying these numbers together, we actually want to look at any common factors that can cancel. So, to repeat the process that we've done last time when we were multiplying rational numbers, we can break the 8 up into factors 2 and 4, and in the denominator I have 2 times 3. This way we can clearly see I have factors of 2 that cancel from the top and the bottom, and we can leave our answer as an improper fraction written as 4/3. Now that we've reviewed the rules for dividing a rational number, we can see and carry that process over to when we're dividing rational expressions. So, for all rational expressions written in the form A over B and C over D, dividing A over B by C over D is the same thing as multiplying by the reciprocal of the second fraction. So we will do the same thing here that we do with rational numbers. So if I have the expression 6x y to the 4th divided by 25z to the 3rd, and then divided by the rational expression 18x z squared over 5y. What we do is copy the first fraction down, which is 6x y to the 4th, over 25z cubed. We then multiply by the reciprocal of the second fraction. So I'll place 5y in the numerator and 18xz squared in the denominator. Then we know that this means we can multiply the two numerators together and the two denominators together. Remember, a shortcut that we've been doing at this point in time is to just highlight the division bar and then multiply the two numerators together and the two denominators together. Now we can cancel common factors and write our result down below. Now we know that 5 goes into 25 evenly, so let's just cancel the common factors in this fashion. So the 5 goes into 25 5 times. This 6 goes into 18 3 times. And then let's consider our common factors for the variables. x completely cancels with the x in the denominator. And it looks like nothing else cancels. So we carefully scan across the numerator. And we've got a y to the 4th multiplied to y for a grand total of y to the 5th. Remember, our exponent rules. Multiplying like bases, we add the exponents. Remember, when nothing's there, it's understood to be a 1. Now let's carefully scan across the denominator. I have a 5 and a 3. Let's multiply our numerical factors together. And then let's multiply our two variable factors together. A z cubed and a z squared. When multiplying those like bases, we add the exponents. So I end up with z to the 5th. And that's our final answer. Y to the 5th over 15z to the 5th. Okay, let's look at this next example. Now we have polynomial expressions in the numerator and the denominator of our rational expression. So this is where we're going to have to do two things at once. We like to factor the first rational expression, and while we're at it, we'll multiply by the reciprocal of the second fraction. So let's do that here. Remember, keep in mind, we have this trinomial to factor first. Since we have a trinomial whose leading coefficient is 1, we know the only way of factoring x squared is x and x. Then consider factors of 16 whose sum is positive 8. Well, that would be a positive 4 and a positive 4. So we've factored the numerator completely. Now let's factor the denominator. Well, 2x minus 2 is just a binomial with a common factor of a 2. When I undistribute the 2, I'm left with x minus 1. Now, let's multiply by the reciprocal of the second fraction. So I'll carefully place x minus 1 in the numerator, and I'll also wrap parentheses around this binomial so that I recognize it as a factor. Now, let's factor the numerator. While I factor this numerator, I'm going to place it in the denominator. Again, keeping in mind that the only way of factoring a trinomial whose leading coefficient is 1 is to break it up into a binomial and a binomial where x is our first term in each. Now, let's find factors of negative 8, or think of it in terms of 8, whose factors give you a difference of positive 2. Again, factors of 8, we could break that up as 1 times 8, but that wouldn't give us a difference of a 2, or a 2 and a 4. Bingo, we've got a 4 and a 2. Now, which product will we give the negative to? We want to give the negative to the 2 because we want a grand total of a positive 2. And remember a way that we can check that process. When we do our outer product and our inner product, we've got a positive 4x and a negative 2x. Remember, this is the multiplication process that you take mentally to make sure that these two products give you a combination of what your middle term would be. And since 4x minus 2x is 2x, we are confident that we've factored correctly. Now that we've rewritten the expression such that the first polynomial, or the first rational expression, divided by the second rational expression is the same thing as rewriting our first rational expression in factored form multiplied by the reciprocal of the second fraction, we're left with the same multiplication process that we've previously done. So what we will do is highlight our division bar completely across, and then recognize that we're simply multiplying the numerators together and multiplying the denominators together. Now, at this point in time, it's possible for us to cancel all of our common factors. So the x minus 1 cancels on the top with the x minus 1 in the bottom, and the x plus 4 on the top cancels with the x plus 4 on the bottom. Then, since we've now canceled all possible common factors, we rewrite our expression as x plus 4 all over 2 times x minus 2. And you can leave the x plus 4 in parentheses if you would like. This is perfectly acceptable for our final answer. Or you could write your final answer as x plus 4 over distributing the 2 through 2x minus 4. But again, please do not be tempted to cancel the 4 from the top and the bottom at this point in time. They are different terms with no common factors. Now let's move on to an example that represents a complex fraction. A complex fraction is a rational expression where we have a fraction in either the numerator or the denominator, or both. So in this case, this is considered a complex fraction since we have an expression as 3s minus 1 over s in the numerator and another rational expression in the denominator. Really, the only thing that makes this different than before is that it's written as a fraction overall. What we can do is rewrite this as a division statement. So I'll rewrite this right below as 3s minus 1 all over s divided by 3s squared plus 8s minus 3 all over s to the 4th. So really, a complex fraction is just a different way of expressing rational division. Now that I've written it side by side, we know the steps required. I'm going to rewrite my first rational expression, which again is 3s minus 1 over s, and now I'll multiply by the reciprocal of the second rational expression. So I'll place the s to the 4th in the numerator and the 3s squared plus 8s minus 3 in the denominator. But while I'm at it, I'm also going to factor. So I'm going to wrap parentheses around my 3s minus 1 in the numerator, since I recognize that that is also a binomial factor. And now, let's highlight what we're factoring right now. We're going to factor 3s squared plus 8s minus 3. And we'll place that factoring right here. So let's consider how to factor a binomial or a trinomial of this form. Since the only way we can factor 3s squared is a 3s and an s, I'm going to place those two factors in the front slots of my two binomials. Then we have to consider the placement of the factors of 3 from the last term in our trinomial. Now we want to place the 3 here and the 1 here, since the outer product would give us 9 and the inner product would give us 1. That gives us a difference of 8. Now, since our difference should be a positive 8, let's put the positive sign in front of the value that would make a product that would be larger. And again, when we factor polynomials, we like to do a quick mental check back to make sure that the outer product and the inner product combine to make our middle term. Since the outer product is 9s and our inner product is negative s, that gives us a grand total of positive 8s, and we're confident with our answer. Now let's cancel all of our common factors that we have on top and on the bottom. Just keeping in mind that at this point in time, we're multiplying two rational expressions, which is no different than highlighting our complete division bar as 1 and multiplying the two numerators together and the two denominators together. Now I have a complete numerator in factored form and a complete denominator in factored form. Now we can cancel our common factors. 3s minus 1 is a binomial factor on top and on bottom. And also, we have 1s factor on the bottom and 4s factors on the top. So this 4 will now become a 3. Now let's carefully scan across the numerator. What factors are we left over with? We're left over with an s to the third, and on the bottom we're left with s plus 3. So our final answer is s to the third divided by s plus 3. This completes our lesson on dividing rational expressions.
Made with Doodlecast Pro.